All right. Moving on with evaluating trig functions, there's a couple more uh, characteristics and different types of questions. We're also going to start talking about trig identities, even and odd functions. And let's start with review. So we know that from the last lesson. And then how are we going to use this? One way we're going to use this is if we know that the sign is positive, then that means that y over r is positive. But we know that r is always positive. So that means that y is positive. And it tells us that we could have an angle in quadrant 1 or quadrant 2. If we had tangent negative, that means y over x is negative. They can either one can be negative, but that means we can have a positive and a negative, or a negative and a positive to make the fraction negative. They can't both be negative. So we know that y is greater than 0 and x is less than 0, or y is less than 0, x is greater than 0. And so this tells us where theta could be. Theta could be where y is positive and x is negative. That's going to be right here. Or y is negative, x is positive, and that'll be there. We know that theta could be in either of those quadrants. We know one trig function, and based on this information we can find the quadrant that theta is in. So let's start with cosecant is r over y. So we know that y is positive. This problem actually gives us, we don't need to know this, we can see this from this, but let's go ahead and analyze it using this. If sine theta is positive, we know that y over r is positive, and that means that y must be positive because r is always positive. So we know y is positive, and that gives us quadrants 1 and 2 where y is positive. Here cosine is negative, x over r is negative, that means x is negative. X is negative in quadrants 2 and 3, and we need theta to satisfy both, so that means it's going to be in quadrant 2. We know that theta has a terminal side, its terminal side in quadrant 2, and we also know that the radius is 2, and the y value is 1. So if it's a special triangle, we could recognize that. 2, 1, 1, 2, radical 3. Or we can just do the Pythagorean theorem and we'll know that's a radical 3. Negative radical 3 because we have to go left to get there. And then they asked for the other functions. So sine is y over r, y over r. Cosine is x over r. Tangent is y over x. Cotangent is the reciprocal. We already know cosecant, so secant is the reciprocal of cosine. And let's change that to that, and we'll change this to that. All right. We know cosine is negative and sine is negative. So go ahead and look at the quadrants where that can happen. Pause the video and try that one. We know that y is negative. A negative y value could be in quadrant 3 or 4. And we know that x is negative. X is negative, so that'd be in quadrant 2 or 3. So it must be in quadrant 3. Theta has to end in quadrant 3. And what else do we know? We know that the radius is 13. If we had a triangle, we'd have 13. The x is 12. We could do the Pythagorean theorem to find the remaining side, and that's going to be (169 minus 144, 25), y equals 5. So when we look at the coordinates, we're going to have, we went left 12, so that's the coordinates are negative 12, and the y is negative 5. And for the other functions, we have sine, cosine we already know. So sine is y over r, 13, negative 5 over 13. Tangent is y over x. We can just do the reciprocals, 12 over 5. Reciprocal of cosine, cosine was given, so we'll do the reciprocal, 13 over 12, negative. And the reciprocal of sine, alright, and then let's go back to evaluating trig functions of angles that could be greater than 1 revolution. 510 degrees, and we can just start going around the circle. We know that's 360, and how much is left after we go 360 to get to 510? We could see what's left. We get 150, so we know that we're going all the way over there, and we have a 100. That's a 150, so we know that's a 30. The reference angle is a 30. Let's look at the special triangle. If that's 30, it's 1, 2, radical 3, and that's going to give us the radius is 2, and then the x value, radical 3, but we went left, so it's negative, and the y value is 1. Cotangent of 510 is x over y, x negative radical 3 over y, 1. And here we have negative 3 pi over 2. There's pi over 2, negative pi over 2, 2 pi over 2, 3 pi over 2. We know it's up there. The x is 0, y is 1, and r is 1. And that's r over x, so we get r over x undefined. Alright, pause the video and try these. Here's one way to do it with pi over 6's and a negative angle. We can just count around 1, 2, 3, 4, 5, 6, 7. We're going to go all the way around to 12, 13, 14, 15, 16, 17. We'll end right there. So we went all the way around there, counting by pi over 6. That's a 30-degree angle. If we look at that triangle with a 30, it's a 1, 2, radical 3. And for the coordinates, we're going to have negative x and a negative y, and with a radius of 2. So for cosine, that's x over r, x value, and the radius. Negative 540. So we go around that far, and that's 360. It turns out 360 plus 180 is 540. So we went negative 540. We're going to be there. And this is negative 1, 0 with a radius of 1. We want the y value over the radius. Now we talk about even and odd functions with trigonometry. We talked about this in chapter 1. An even function has symmetry to the y-axis. If it has symmetry to the y-axis, then you could have points like this, where if that's a, then that's negative a, and it has the same y value. So we know that f of x is the same as f of negative x. That's the characteristic of even functions. And we can see that cosine of pi over 4 and cosine of negative pi over 4, they both equal the same value, so we change the x value, change the sign, we get the same y value, so it turns out cosine is an even function. And we'll list all the functions. Here, if we talk about an odd function, that means it has symmetry to the origin. And when we look at that, if we had at a positive y value, then at negative a, we have a negative y value. And it turns out that sine is odd. Sine has this characteristic. And here's how we can memorize these. The only even functions are cosine and secant, and it has, if you have a theta or a negative theta, it doesn't matter, you get the same y value, and secant is the same. Those are even. Everything else is odd, so when you change the sign of theta, you get a negative y value. Negative y value. And those are odd. And then we can see some questions using this identity. All right, when we do this, when you start using identities, you want to look at what we're dealing with, what we're asked to find, and what we're given. Everything that we're considering, we want to write down the possible identities that we might need. So if we have sine, cosecant, why don't we write those down, and it might give us some ideas of how to do it. So let's look at a list of identities to consider, and we're using sine, so let's write down this. And we're also considering cosecant, so let's write down that. So then we don't have to look at the whole list, we just want to focus on these. We will be learning over 30 identities, so this is a good strategy to narrow down your choices. Alright, and if we need to find sine, we have to use what's given to write out something that has sine theta. We don't want to know sine negative theta, we have to know sine of theta. So we know that sine of negative theta is negative sine of theta. This is the identity, and let's substitute. Sine of negative theta, we know what that equals. 5/9 is negative sine theta. We're trying to find sine theta, so now we'll just multiply by a negative, and we get that. We don't have to use this, because now we can just do the reciprocal of that. Um, all right. Write down the identities that we might need, and then try to use one and substitute to find out what we're trying to find out cosine and cosine of negative theta. Pause and try that. What identities might we need? Well, we'll write down the identity for cosine of negative theta. And we also have a secant, so let's write down secant of negative theta is secant of theta. They're both even. And let's start with what we're given. We're given this, so let's use the identity containing that. We know secant of theta is 2, so let's substitute that. And looks like we're kind of stuck. That's not getting us to where we want to go. When we're using identities, sometimes we try something and then it leads us nowhere, so we just start over. And if you want to just cross that out. Instead of that, why don't we say that we know that cosine is the reciprocal of secant, so we'll do 1 over 2. And we've just found the cosine. Now we could use cosine, use this identity. We know that cosine is a half, and so we'll just substitute that. So we tried, based on our list, we tried one that didn't take us anywhere, so we started over. And let's just had to rethink it. Secant is 2, so we want cosine, and that's the reciprocal. So we could just say it's going to be a 1/2. Pause and try that one. All right, cosine, secant, cosine. So let's write down the identities. Cosine is the same as cosine negative theta, cosine theta. Secant negative theta is secant theta. And I wasn't writing these before, but let's write these. Cosine of theta is 1 over secant, and secant is 1 over cosine. So we have, what we're starting with is cosine, and we want to go to cosine, so we should be able to use this. And then we can just do the reciprocal for secant. Let's copy the identity that we think we're going to use. And we know what this is. That was given. Radical 2 over 2, negative radical 2 over 2. So now we know what cosine is, and it asks for cosine. So let's find out secant. Secant is the reciprocal of cosine. And we get negative radical 2. And we'll stop there.